Everyone, I'm Brian Hogan, and I'm going to be going over Intro to Shell Programming Part 2. For those of you who are looking for HPC and engineering, that talk has been moved to Thursday at 2:10. Do we have people from the WebEx? Yes. Okay, so if you have any questions from the WebEx, click on the chat box, send to one, and then type in, we'll try to take them over. Okay? Just if you want to look on the first part, this looks like. But I'm going to pick up where we left off last time. So why shell programming is part of the setting up? One of the answers today, the majority of the portable back system emission chips are living in back. This lab clusters and physics use three post-processing steps and automated process using batch. One is monitoring analyze input or output. Jump right into it and go before this patient. Now, this slide was in the previous. Basically, I would like all the users who are watching to participate in typing these commands in their own shell. And get used to programming. See also free links provided on the website. People shut up at home. But I mind now, if it's time I need to start off with archive data, for example. So let's suppose you have a program which generated output files for density, velocity, and temperature, and those files are called den.net or del.net. So this is about to show you. It's going to copy the files into a folder based on everything. And it's going to part. So let's create these .NET files using IO redirection. Is there anything? Okay. So go ahead and generate the .NET files. So what I'll be doing is I'll open up the terminal and I'll just echo this line and have these values go into the file type. Switch keys. Open the terminal. First command -b input 2.0 input 5. Now the values are just you can put any values you want. And no, again, tell me now. You put any values. Anything familiar with the notation you see here? The dash E is for interpret these // characters. This /n means it's a new line or hard return. And the greater than sign means have your output go to the terminal. The number will be directed to the file that we specify. Then .NET, del.NET. So if you want to content of these files, you will have line is just a setup test file, basically simulating as if the program had been on the file. So now let's go to the script. What I'm going to do is I'm going to get today's date, and I'm going to put in the format of the month, the underscore, the day, underscore, the week. Got it. Please print this. And then I create that directory after I define it. And for every .dat file, I'm going to copy it to this new folder, using the for loop. I'm going to archive it with the target. Type this full script in the editor, and then those of you who aren't familiar with Linux editors, I'm going to be using Nano. That's pretty straightforward to use. VI or Emacs within in that. Today's variable file underscore day. And I'm going to run, remember to run a command, use the $sign parentheses, and anything in parentheses is being run, and the output will be set to the same. Run the date. Then create that directory. Right there, and then I want. So I put the value today in this variable. I want to use that variable. The reference is again the $sign. Okay. And then for every .dat file, copy it to folder. Syntax is for your, in this case, I'll call it laptop or that. And on command ls star.dat. So basically, it's gonna run this for loop and do every .dat file we have in the current frame. Assign this variable to each of them in order. So in this case, the first value would take on then .dat, and then this is the temperature of that. I want to see it has to be just verbose file to show what's happening. Now, when you use the file, and I want in this newly correct. And then I want to go to directory and archive. Archive. I'm going to call it archive data. We're going to see all the data file. Afterwards, I want to remove it. Remove all that file, so I'm just left with the archive. And then I'll go ahead and I think the time do that. Simply, what I'm doing right now is I'm going over concepts that I covered in the previous session. naming a value to a variable, and then in this comes the value command using dollar parentheses. A variable by referencing it again with a dollar sign. And then I'm doing the for loop. I'm saying this is my variable, I call it dat file, and it's going to loop over every single dat file that I have in front of it. Which, if you're following from the previous example, move it into this folder, and with folder, I'm going to type it, and then remove all the single files. All these well, it's a for loop, and it's a for construct, because we need to have do and done to specify what needs to be done in that for loop.
The argument list for the for loop, how to understand it is like.
Okay, so basically, my file is my variable that I'm going to iterate. Okay, and it's going to take every value in this list. And this list is generated by running the command ls star.dat. So basically, it's going to go over every file that I have that has .dat.
What are the files in front of the reference?
Is there a dollar sign right here?
Yeah.
Basically, that means I want to run that command. And you put at the list things to move over. So that's okay, so if you don't know how to save in Nano, you do Control X, save the buffer, yeah, and then the file name is okay, and hit Enter. To run it, make it executable user, ch5v plus x. So if I do an ls my current directory, we should have the 3 dat files in the script. You can see the script is indeed executable with this little x right here. So we just hit ch command. Now I can run it. The file I moved to a folder that was generated in today's date, 11/12/13, and then this A we added to the archive because I told it to the -b file. So again, you can see I now have a directory 11/12/13. I now have the archive, which is now pressed. If you want to find something, give you more distraction. There you go. So let's go to move it. These files that you generated into the folder on today.
You can go more over the
okay. Clear. Put it in there. Do you have a specific question?
Just going over.
Okay.
Like, what is it doing?
Okay, so the first part was the shebang. This specifies which shell you expect for using the bash. This comment is going to be more we have a variable today's date. Okay, and what we're doing is trying to output this command to that variable. Okay, we do this on the command line. command, you would do 11 volt. And you can set however you want, based on which cabinet close. Like in our previous example, I have slash and the date. So basically, I have this command, and I want the output to be saved into a variable. Now, it contains what the output of this command. Okay. So I wanted to create a directory with that name, so I use make dir, and I use the value of the and to get the variable, you use the $. I just said I wanted to move all that in folder that I just created. So in the for loop, I create a new variable to the loop of called that file, and I type on every argument from this command. So start up. Go to the command line. So basically, variable that file will first have this value and this value. Okay. So it's just for that file and not that. So you can see over that file with this variable first. This is first. Oh, yeah. And then this value next. And then that's going to have this value for the last one. So that's a for loop in a nutshell. Alright, so let's go back to here. Then the final thing I wanted to do is I wanted to go into that directory that we just made, so I changed directory. And then I wanted to use the tar command to archive it. And I passed these flags so I can see what's happening. I wanted to give this name, archive, and I want to archive all of my data. And after I just want to keep that off, because I now have a version. So move and see what's happening. I promise I'll do the rest of the script. Now we go to what's called test. Evaluate conditional expressions. True or false. I use command S by itself, followed by an expression, or you can hand notation with the bracket. For sure that if you're using the bracket expression, that there's a space after the first one and before the last one. What's kind of weird about the test utility is if the expression evaluates is true, a value of 0 is true. The expression evaluates false is at 1. And if the error is never good, most and you can return value by using $. Okay. So what do you test? Well, you can compare yours. If you have two years, you can see if it's equal to, not equal to, greater than equal to, less than, or less than equal to. Following this syntax. And if for the brackets, you can just have the word test. Additionally, instead of use these letter combinations, you can use the equivalent symbols, less than and greater than, but you can have to escape them with the /. And one common pitfall is actually using equal sign. So the equal sign, be sure to to tap basic knowledge. Not test 5 equals 4. To know what that result was. I know the question. So does 5 equal 4? No, it doesn't. So the answer is false. So the answer is 0, 1. Is 5 5? The answer is 0. Okay. And with the other message, 5 equals 4. Earlier, greater than 5. We have a mistake. 5 greater than 5. No, it's 1. It's 5 greater than 4. That is what you're referring to. Okay? So this is used in conjunction with if statement. You know, if a certain condition is true or if it's false. Most of the time, you won't even be concerned with the dollar question mark value because you're just concerned with whether it's true or false, and you act accordingly. But if you ever wanted to know, you can always take the dollar question mark. Same can be done with strings. If you wanted to see if a string is non-zero, you'd use -n. This is a unary operator because it's only operating on one thing. You can see if the string is empty or a zero string. Then -2. You can see if two strings are identical with an equal sign. And you can if they're not identical with not. If you play with that, say string 1 equals hello. If it's non-zero, zero string, and equal to each other. String and equal to each other. They're not equal to each other, so one is it's false, so it returns a 1. Why is it? Depending on whose script you're looking at, you might have through the test of brackets. The brackets is kind of more readable, remind me. Okay, so we do that for strings. Same thing can be done with files. You want to see if a file is a directory or if the file even exists. You know, if it's a shortcut, a symbolic one. Can you actually read it? Is there stuff in it? Is it writable? And has it been modified since you read it last? Now this is just a snapshot of the most common file tests. There are other things you can test as well. For the most part, these are the most common. And if you compare two files, you can see if one file is newer than the other. You can also opposite, see if one file is older than the other. And you can see if those files are pointing to the same thing. That also do integer arithmetic for you. Basically what you would do is you'd use the $sign, and at this time we'd have two parentheses in the expression. For example here, I said count equal to 1, and I just want to add 2 to it. So I say count equals, evaluate this arithmetic expression, 2 plus count. Here's my so the point here is that the $sign does not need to be in front of count variable if you're forming arithmetic expression. If you're dealing with input parameters, you still need the $sign. For instance, if you wanted to add the second parameter, you put $2. And I show that rule, but here it's count equals 1. Count equals, evaluate this arithmetic expression, 2 plus count. So now count should have a value of 3, which it does. Okay? Thank you. All right. Right along. So this example here can also be done with using the let statement. You see this in some scripts. Instead of the count equals the whole $sign parentheses expression, you can simplify that by saying let count equals count plus 2. Or even further, you can do like the C notation, let count equals plus or equals 2 for short. I'm going to show that real quick. It looks like we set count to 1. So let's let count equals count plus 2. And then add 3. And then and reset it. Let count closer to 2. That equals 3. Okay. Now, let's see. I also treat these arithmetic expressions as commits themselves. Basically, if you want to evaluate the expression, it will give you a 0 if the return value, if this expression evaluates to 0, it will give you a return value of 1. If the expression is non-zero, it will give you a return value. For example, 3 plus 3 6 non-zero, so it should return 0 here. And 3 is 0, so it should return 1. And the result, 6 is not 0, so you should get, is that right? It's non-zero, so it should return 0. I was getting confused. That's what I thought it should be. So, as for is 0, so 1 would be 0. I remember. Okay, I've shown you all these tests. Basically, you're going to want to use them if and control like that. If it's true, then you use it up. And that it's common practice in debt, and then again put the end for weeks, but it's not a strict requirement. And every if, you need to close it with an F, with a backwards if or an FI, to signify, that was if and controls. For instance, if, variable age is greater than 18, then do something. And then And C, another programming languages, you can do it else. If this test command is true, then do this block command. If not true, then you should do these block commands. And again, you close it with the backwards with that box. And if you wanted to, you can use a semicolon and move the then up here. Yeah, this then up there, just for readability sake. It does exactly. And you can even further with else if. So if some command is true, then do that. Else, if some other command is true, then do that. And you can nest that as many times as you want. But like I said earlier, for every if, there is an FI. Okay, so there might be times where you want to use that command while something is true. So that's going to show while control structure. In this case, you do while and you test command. Do and done signify what you do by. In this case, I'm going to echo this example. I'm going to echo the content of input1.n. I'm going to read the file. I'm going to do one, basically, content of input1.n. Each one is going to be some variable line, and I'm just going to take it out from the console. So go ahead and let's create an input1.n. So input1.n. And I'll just create some random from dot at out. Whatever you want. And I'll save it. Control X, Y. Okay, so let's do a script called while test. Save. Name. So what this shell script is going to do is going to echo the content of input1.n. So while read line do line done, and that is the input redirection here. Instead of getting it from the keyboard, I'm going to redirect it from this file, input1.n. So, give people to type that. This is a fairly common use of the while statement. You want to read a file and do something with the contents of that file, and you can actually give the file to the while loop using this input redirection. So again, it's reading every line of this file until there are no lines to read. I'm going to save it. Control X, Y. Again, get executable on me. And go ahead. So, what it did was, for every line in our input file, size variable. And just get it back up. Any questions? That's the while loop. Similar to the while loop is the until control. The while until the test command is true, use reverse false. Loop will continue. And if you ever want to add a loop move on to the next iteration, you do break for a while or until the function is interrupted. You can break or continue statement. Basically, what break does is it'll stop execution of the loop and then begin to pick up at the end of the done statement. So it'll go to the done, it'll start executing statements immediately following the done statement. Continue will jump to the done statement and go on to the next iteration, basically skipping everything in between the continue statement and the done statement. Okay, this is similar to what you have for breaking. Okay, except the case structure. This is kind of like the switch statement in C. I don't know if you're familiar with that. Yeah.
Question on the before command. So it breaks from the innermost loop element, or it breaks for all the loops?
Yep.
So you have like two loops, one inside of the other.
It'll break the so don't so if you have four bars, and then you have another four bar two, and then you have a two. I'm done. If the break was in here, it will only break out this first loop. It will still continue along the outer loop. Okay. Now, however, if your break was outside of the second loop, it'll break out of this first loop. Does that answer your question? It depends on the placement of the break or continue. So no. To the case structure. This is like the switch statement. Basically, if you give it a test string, it's going to see if it matches any of these patterns. And if it does match a pattern, it will run specified condition. And this is syntax. The two semicolons to know that you're about to start a new pattern. And in order to close out the case statement, you use the backwards spelling case, which is ES6. So I got an example over here. Basically, I'm going to prompt the user to enter a letter, either A, B, or C, and I'm going to run a case statement on that letter. And if it matches A, I'm going to echo you chose A. Matches B, I'm going to echo you chose B, and so on and so forth. If it does not match any of the A, B, or C, I'm going to say you did not choose properly. I'm going to close out the case. Go ahead and type that in. Let's call this case example. Shipping. Alright. Read dash choose A, B, or C. Now I'm taking the variable called that number to the square. So I'm going to run a case statement on that letter. Give it its choices. And leave it A. Or and anything other than that with the wildcard. Oops, I forgot my code. So keep those. Divide the choices. You did not choose. People unexpectedly. If you're not familiar with this first one, it's basically going to print out that let's choose either A, B, or C, and it's going to prompt for a value. And it's going to assign that value to the variable letter. And then I'll use the value of that letter in the string with the put, and I'm going to compare it against this pattern, A, B, C, or wildcard, or everything else. Okay. So I'll save it, control it. Make that feel good. I forgot. Actually, let me break that. Control it. So I chose A. It's matching what I input into the internal. And if I give it a value outside of range, it's going to be output. And case sensitive. So if I put lowercase a, except I yeah.
Once you find one of the cases breaks out, or you keep trying the next one?
So once it matches it, it'll execute all these commands until it reaches these double semicolons. And then it does break out after the case because the match was found. And it did what it was supposed to do. Okay? Yeah, it breaks out, it does not.
If you have another, you have to put a break, otherwise you will find the other one.
Oh, yeah.
The double semicolon is like the break out.
I think it's the final thing I want to cover is the select control structure. Basically, you can create a nice menu formatted with numbers before each item. You can select, you give it a variable that you want to assign a value to, and give it some arguments. Then, based on what the user input, it's going to do something. The user selection number var native, whatever variable we select, will be set to the appropriate argument. Okay. And that looks pretty big. So let's do this example. So I'm going to create a menu from input files using select. So this example only accepts input 1.in, but you can modify it however you please. Basically, what it's going to do is it's going to show you all the .in files that you have in your directory, and it's going to ask you which one of those you want. It's going to take that value and put it into this variable option. This I'm going to test and see if input 1.in was selected. Then I'm just going to show you. I'm just echo that out and then break out of the select statement. If I don't break out of the select statement, it's going to repeat it like you're talking about. And then for this example, if I don't select it, put 1.in, it's just going to tell you that's not a valid choice. It's a pretty vanilla example of the select statement. But I wanted you to see how it could. Yeah, first of all, I want to give it one command ls. I do not. Testing the expression. That's my file. Time I do it in the file. All that is do all of this. I echo the dollar option. But if it's not, I use help me. Not sure. So this one, and brothers. So we can also just take this file and then run our script. Get an LSI and it shows you that, hey, you have three input files here. Which one of those do you want? So you give it a numeric value. Say I want an input zero here, not a valid choice. And then it goes back to the prompt, because in our wildcard, or I mean, output, do not have a break. So it goes back to the prompt asking what you want to select. But so I put that in. Yeah. It's just a string. Yeah. What happened?
You know what, to use the screen is you have to use the CMP. Here,
Okay.
a little bit more with the,
Okay. Right. I don't think I did it. There you go. So I did it. Reference. My phone was off. Oh, I lied. I didn't type it in the example. Sorry about that. I didn't work. So if value this variable contains input 1 on n, and then it's going to show you that, and it's going to break. As you can see, if I did 1, 2, 1, it'll break down. So you can see how you can set this up. You have different steps. You can you don't have to do this. I'll start out. You can say, manually say, I only want to accept input 1 and input 3 on it. Right? In which case you have 2 choices. Right there. You know, there are times when the sales group or something that is doing something unexpected and you want to try to figure out. Which is you can either call script, use in dash, pass it the dash x parameter around the script. You can insert the line set dash x near the top of the script, or modify the shebang. Additionally, you want to see the values that you're doing, you can use dash X. I'm going to show that real quick with sample archive data. Slash bin dash archive data. These pluses need the command W plus, that this is what the output is terminal. In this case, new file. And you can run through it line by line to see what you don't have to do, there are three ways to do it. You can go back into the file, name a set dash X. This time, just call it normally. Edit anything. Or you can modify the shebang, the dash X there. And all three of these do the exact same. This is what we're trying to do about the bash script. Okay, so these are some references that I used. These are nice to get into bash scripting. Practical guide will expand editors and shell programming and bash scripting. You can Google online. Use Google to see what other people have done with bash. I'd like to note the slides and the previous slides that I have from the last session are available here at mix.ncw/hbc-seminar-series. Actually, /app. Are there any questions?